Assalamualaikum and very good morning to Puan Rohina binti Jaafar, lecturer in Principle of Electrical and Electronic BMMA 1313. My name is Muhammad Shazwan Zulhilmi bin Muhammad Qasim and I'm from BMMH. Today I would like to present my presentation, which is diode, forward bias and reverse bias circuit. Okay, first I will explain about forward bias. Forward bias occurs when the complete circuit is connected with a semiconductor. In a semiconductor, it will contain two types of material, which is p-type material and n-type material. Forward bias work when the positive terminal of the voltage source is connected to the p-type and the negative source of the voltage will connect to the n-type material, and hence it will become a complete circuit of forward bias. The current that flows in this complete circuit will be in high current. Okay, now I will explain how forward bias occurs. Forward bias occurs when the positive terminal of the voltage source is connected to the p-type, and the negative terminal of the voltage source is connected to the n-type. In the beginning, there is no current flowing through the diode. This because, although there is an external electrical field applied across the diode, the majority charge carriers still do not get sufficient influence of the external field to cross the depletion region. For your information, the depletion region also acts as a potential barrier against the majority charge carrier. This potential barrier is called forward potential barrier. The majority charge carriers start crossing the forward potential barrier only when the value of externally applied voltage across the junction is more than the potential of the forward barrier. As we know, there are two types of diode, which is silicon diode and germanium diodes. For silicon diodes, the forward potential barrier is 0.7 volt, and for germanium, it is 0.3 volt. When the externally applied forward voltage across the diode becomes more than the forward barrier potential, the free majority charge carriers start crossing the barrier and contribute the forward diode current. In that situation, the diode will behave as a short circuit path, and the forward current gets limited by only externally connected resistor to the diode. Finished in explaining of forward bias. Now I will explain about reverse bias. First, it will occur when the diode is being inverted, which the p-type connected to the negative terminal of the voltage source and the n-type connected to the positive terminal of the voltage source. Due to the inverting style, the current that produced in the circuit is in low current or no current at all. As we can see in reverse bias, which is the negative source of the terminal is connected to the p-type and the positive terminal of the voltage source is connected to the n-type. At this condition, due to electrostatic attraction of the negative potential of the source, the holes in the p-type region will be shifted more away from the junction, leaving more uncovered negative ions at the junction. In the same way, the free electrons in the n-type region will be shifted more away from the junction towards the positive terminal of the voltage source, leaving more uncovered positive ions in the junction. As a result, the depletion region becomes wider. This condition of a diode is called the reverse bias condition. At this condition, no majority carrier cross the junction. Instead, they move away from the junction, which means that the diode blocks the flow of current when it is in reverse bias. There will be free electrons in the depleted semiconductor and some holes in the entire conductor. These opposite charge carriers in the semiconductor are called minority charge carrier. In this condition, the holes find themselves in the n-type side will easily cross the reverse bias depletion region as the field across the depletion region does not present, rather it helps minority charge carrier to cross the depletion region. As a result, there is a tiny current flowing through the diode from positive to the negative side. The amplitude of this current is very small as the number of minority charge carriers in the diode is very small. If the reverse voltage across a diode gets increased beyond a safe value due to higher electrostatic force and due to higher kinetic energy of minority charge carriers colliding with atoms, a number of covalent bonds get broken to contribute a huge number of free electrons, hole pairs in the diode, and the process is cumulative. Okay, now this is the graph for forward bias and reverse bias. For forward bias, as we know, the current flow is high. Thus, when it reaches the potential barrier, it will become high current. For reverse bias, it is completely upside down, where the current that flow inside the circuit will be in low current, and thus at some point it will reach the breakdown voltage and no current is transferred along the circuit at all. I think this is the end for my presentation, and I would like to thank Puan Rohaina for giving me an opportunity to present this chapter. So that's all for me. Thank you and have a good day to you, madam.